Hello everybody, this is the fourth lecture regarding to the basic mathematics learning for physics learning. So we are going to learn about the differentiation. So we are going to learn about the differentiation. In the next lecture we will learn about the integration, then graph, then we will be done with the basic mathematics thing, and then we will move to the error analysis. So first, what is differentiation? Differentiation is the rate of change of any quantity. Rate of change of any quantity. Okay, this is the rate of change of any quantity. What does it mean by the rate of change? I am talking about this thing. What does it mean by rate of change? So let me explain what does it mean actually. So let's say at t equal to 0, x was 4. Okay, 4 something, it can be anything. So at t equal to 0, let's say Ram has 4 mango, and if I am talking about 4. Oops, let me delete that thing. So at t equal to 0, number of mangoes was equal to, let's say, 10, and at t equal to after 1 hour, okay, after 1 hour mango remaining is 6. So if I will ask how much the change for the mango, so the change for mango, if I am representing it by delta m, this is the change of mango, will be, earlier it was 10, now it is 6, so it has got changed by 4. Okay, so if I will it has got changed by 4. So let me do it like this. Final mango of final numbers minus mango initial. So the change is what? 6 minus 10 equal to minus 4. Means minus 4 means what? 4 mangoes has been consumed already. So if I will talk about the rate of change of consumption of mango, will be equal to delta m by delta t, that will be equal to minus 4 by 1. So at each hour, for each hour, in every hour you are consuming 4 mangoes. So this is nothing but the rate of consumption of mango at per hour. Okay, so per hour you are consuming the mangoes at the rate of 4. Okay, this is the differentiation. Okay, so right now I was talking about a big difference. Okay, let's say another example. Let's take at t equal to 0, let's say a person is at position of x equal to 10 meter, and at t equal to 60 second the person is at 50 meter. If I will ask you what is the speed of the man or the person, so what you will do? You will do what? Delta x by delta t. How much it has got displaced divided by how much time it has taken. it will be equal to speed. Okay, so it has displaced to 50 is the final minus 10 divided by 60 by minus 0. So that will be equal to 40 by 60 meter per second. That will be equal to 2 by 3 meter per second. Okay, so this is the speed of the person. So this is nothing but the differentiation. Here the change, what you are doing for speed, you are taking the how much distance it has covered, final minus initial. This is what you are doing, the position final minus position initial divided by how much time it has taken, the time final minus time initial. So this speed is nothing but the differentiation of the displacement divided by time. Okay, distance divided by time. So this is the differentiation. If I'm so let's just move to the basic formulas of the differentiation. This is the overview of differentiation. So let's just move to the formula of differentiation. So first one is, so I was talking about one thing. So right now we were talking about all the things which are having a big changes. Okay, what about a very small change? That was a very big change, that is speed. What if I am talking about for a very few interval of time, let's say it is dt represents very small interval of time. In this dt time, it has traveled dx distance, then the speed will be dx by dt. Okay, so this dx by dt is nothing but the rate of change of x with respect to time, and that is called speed. Okay, or velocity. Anyhow, speed and velocities are not equal. We will discuss about this thing in the vector chapter, but for now you can understand it it as like this only. So let's just move to the basic formulas. What will be the differentiation of a constant with respect to any variable? Okay, let's say it's dt or anything. So constant, differentiation of constant with respect to any variable will be always 0. Why it will be 0? Can you just explain it to me? Let's say, for example, this is y, this is x. Let's say constant function means what? Constant function means the value is not going to change. So if I will talk about this thing, let's say this is 4. So whether the value of x is anything, it doesn't depend. The value of y is always will be 4. So you can see the final value will be equal to initial value. Okay, let's say this final y represented by y. So the y final will be equal to y initial. So y final minus y initial will be equal to 0. So rate of change of change of y will be always 0, because it is always constant, it is 4. So the final initial value will be always equal. So delta y by delta t will be equal to 0 for a long interval of time. Any interval of time means delta y by delta x is always 0. So even if you get it for the very small change, the dy by dx is always 0, because y is constant. That's why the differentiation of a constant is always 0. So let's just move to the next formula for the differentiation. Differentiation of x to the power n differentiation of x to the power n with respect to x. So always remember, it will be equal to n. The power will come into the multiplication of x to the power n minus 1. Just remember, it will always be reduced by 1, and the power n, this power n will come as a multiplication of the number. Okay, so what about the differentiation of logarithmic function? Differentiation of logarithmic function with respect to x, that will be equal to 1 by x. Okay, differentiation of sine x with respect to x. Just remember, if the angle here, okay, if the angle here is x, it is being differentiated with respect to x. In that case, the differentiation of sine x will be cos x. Okay, differentiation of cos x with respect to x will be equal to minus sine x. Okay, differentiation of tan x. So before going for differentiation of tan x, I just want to let you know the differentiation of multiplication of two numbers. Let's say there is one function f1 which is function of x, there is another function f2 which is also function of x, and we have to find the differentiation of multiplication of these two. What do you need to do? Nothing. Take one as a constant f1x, differentiate the other df2x by dx, then take another one as constant f2x constant and differentiate the first one df1x by dx. Fine. Let me tell you some example how you're going to do that thing. If I'm asking you the differentiation of sin x into cos x, okay, with respect to x, with respect to x, so take sin x as constant, differentiate cos x, that will be equal to the differentiation of okay, so taking sin x as constant, differentiation of cos x with respect to x, plus take cos x as constant and differentiate sin x. So if you will see it here, sin x, differentiation of cos x is minus sin x, so take minus at the front, plus cos x, and differentiation of this sin x will be cos x, so that will be equal to cos square x minus sin square x. Fine. So this is how you are going to get the differentiation of sin x into cos x using the formula for multiplication differentiation theory. This is not a theory actually, this is only a formula. So what about the division of the two functions? How to get the value of differentiation? So what if we have to find the differentiation of f1x divided by f2x with respect to x? So now the function has got divided, f1x is being divided by f2x, and we have to find the differentiation of this division. So the formula will be like this only: f2x differentiate f1x with respect to dx. minus f1x differentiate f2x with respect to x divided by the denominator. The denominator was f2x whole square. Okay, just remember this formula. So how we are going to implement this formula? Let's say if we have to find out the differentiation of tan x. Okay, differentiation of tan x with respect to x. So how we are going to proceed? We can write tan x as sin x divided by cos x. Okay, so you can see it right now. This sin x by cos x is nothing but the division of sin x by cos x, and we have to find the division of the differentiation of this division. So we can apply the above formula. Which one? This one, this one, this. This formula we can apply for the division. What we have to do? Nothing. Just remember, stick with the basics. So here the f2x is cos x and f1x is sin x. So cos x will come as constant, and we have to differentiate sin x with respect to x, minus second one, sin x will come as constant. We have to differentiate cos x with respect to x, and the denominator will get squared, cos square x. Fine. So the top one will be cos square x, because the differentiation of sin x with respect to x will be equal to cos x. Cos x into this cos x, that will be equal to cos square x, and sin x minus sin x, and the differentiation of cos x with respect to x is minus sin x. So divided by cos square x, that will be equal to cos square x plus sin square x. This negative will become positive, divided by cos square x. Sin square theta plus cos square theta, or sin square x plus cos square x is equal to 1, divided by cos square x will be equal to sec square x. Sec square x. So the differentiation of tan x with respect to x is equal to sec square x. Okay, similarly you can find it out for cot x. What you have to do? Let's say this is the assignment for you guys. You have to find the differentiation of cot x with respect to x. Let me provide you the answer and try to match it with the answer. The answer will be minus cos x square x. What you have to do? You have to write cot x as cos x divided by sin x. Use the formula of division for differentiation and you will get the answers. Similarly, the next question for you, please try to solve it by yourself. Differentiation of sec x. Stick with the basic formulas. What are the basic formulas? Very basics. One is for division, one is for multiplication, one is for sin x, one is for cos x, one is for x to the power n, one is for constant, one is for logarithmic function, nothing else. Okay, just try to stick with the basics, you will get to know. Okay, so the sec x, you have to find it out, and the value will be sec x into tan x. How to do this differentiation for sec x? What you have to write? Sec x, you can write it as 1 by cos x. And now you are seeing it as division of 1 divided by cos x. Now you can use the formula for the division, and you will get to know what is the differentiation of sec x. Try it by yourself. Okay, unless until you are not going to trying it by yourself, it is not going to help you and not going to help me. It is the waste of the time for both of us in that case. What about the cos x? The value will be cot x into cos x. How we are going to solve this cos x from differentiation? Only you need to do, you can write it as 1 by sin x, and 1 by sin x is nothing but the division of 1 divided by sin x, and you can use the division formula. You can do it. Cos x into differentiation of 1 minus 1 into differentiation of sin x. You can write it like this. Okay, you can use the 1 by sin x formula. Since the cos x is 1 by sin x, you can use the basic thing. So let's move for the last one, which is differentiation of e to the power x dx. So just try to remember, here power of e is what? X. So differentiation is happening with respect to x. Okay, in that case the differentiation of e to the power x is equal to e to the power x. Okay, so this is all about the differentiation. We will move to the integration part in the next lecture and try to solve this 3. This is going to clear your concept about the division of two function, f1x divided by f2x. You have to find, let's say it's zx, and zx is f1x divided by f2x, and you have to find the differentiation of zx with respect to x, where zx is f1x by f2x. Okay, stick with the basic formula, f2x into differentiation of f1x minus f1x into differentiation of f2x divided by f2x whole square. Use the same formula for the differentiation of tan x, cot x, sec x, cos x. Try to find rearrange the equation in the division form. Okay, and you will get the answer. Okay, so that's all about this lecture for differentiation. We will learn about integration in the next lecture. Till then, bye bye. Thank you very much.